Good afternoon, everybody. This is Mr. P here. I'm here at JFK Airport, and since I'm here, there's so many interesting things going on. There's a lot of movement. There's a lot of different types of transportation. You can see over there, there's a rail there that takes people to the different terminals. It's a tram there, right here. It's coming up. This is where the planes are getting launched. I'll show you over there. There we are. They're taking off over there. There's a runway down there. Okay, and beautiful weather out after all the snow we've had. There's still snow on the ground, but actually I'm here to take someone who's leaving to another country, and I thought it was such a beautiful day and nice place to do a math problem. Math is going to follow you everywhere. It's going to haunt you with math. Wait, here comes the train right there. I just want to show you this takes you to the different terminals. Here it goes. Ready? And I'm going to give you a math problem. Here we go. All right. There's some airplanes down there. Maybe we'll catch one taking off. So you know what? I'll stand just like this, just in case a plane takes off. But we recently did factoring quadratic expressions and using factoring to solve quadratic equations. So I want to use that skill right now to solve a math problem related to airplanes and height. Let's see if we can do it, okay? Let's imagine that a plane is taking off over there, okay? And let's imagine that when the plane gets to 400 feet, something gets dropped. Let's imagine someone drops something from 400 feet. Let's say wind, the effect of wind is negligible. And let's say it's a pretty heavy object. Oh, there we go. There was a plane right here. Okay, nice. All right. So this is a more interesting view than just that plane, huh? It's the real deal, baby. Okay. So here's the math problem. Let's write a function for the height of the object that is dropped, okay, in terms of time, okay? Tick, tick, tick. As time goes forward, the object goes down further, okay? So let's write that down right here. My little working table here. It's the only piece of paper that was available, but we're going to see if it works. Okay, you guys remember the force of gravity? How that works? Height equals -16 t squared. That's the effect of gravity pulling down on the object. Okay, where t is time in seconds. Okay, and let's say we're dropping the object at 400 feet. So that's the starting point. That's our... We normally call that a y-intercept if we're dealing with linear functions. But here it's just the starting point. It's the value of it's the height when t is 0. You can pop in a 0 there, you're left with 400, okay? But the question is, after this, there's an announcement. This is just like at school, the intercom, we have an announcement, we have to stop the lesson. Don't accept. Don't leave luggage unattended. Search your luggage. Don't accept any gifts or anything from anyone, any strangers. Okay? We had to stop the lesson, just like at school. Alright? We had an announcement. Okay, let's get back to the problem. Okay, so here we go. Height equals -16 t squared plus 400. When will the object hit the ground? That's our question. After how many seconds? Okay? Let's check it out. Can we solve this by factoring? Well, if we're hitting the ground, the height is 0. So we could put a 0 there. Equals -16 t squared plus 400. This is pretty tough to solve just by itself by hand like that. So let's see if we can factor this expression. And what's a common factor that we can pull out from this term and this term? Well, there's -16. Up there's an airplane. There goes one. Oh, we missed it. Okay. How about -4? Pull out -4. What's left over inside? 4 t squared, boy it's cold out here, minus 100. There we go. So we just factored that partly. Can we factor it more? Does anyone recognize what this is? We just did that in our other lesson. on factoring. Do you see a perfect square here and a perfect square there? That's right, it's a difference of two squares. Why don't we factor that? We can do that. So it's a little tricky here, but we're going to go 2, and now we're going to use x's and y's, okay? We're going to use an x instead of t. So that's 2x, because that's the square root of 4x squared. And what's the square root of 100? That's right, it's 10. So we go 10 here, plus or minus, plus and minus. 2x plus 10, 2x minus 10. And we're left with the negative 4 out here, which you can keep it out there, equals 0. So here's the question. What's the x value that would make this whole side equal 0? If we can get that, we'll get our answer. Okay, do you remember what I told you? Remember the strategy we used? We have binomials now, so we can set each binomial equal to 0. People are starting to look at me now. They're like, what the heck's that guy doing over there? Okay, but you guys know what's the deal. Here we go. Okay, so let's do it. Let's set this one equal to 0. 2x minus 10 equals 0. And let's watch what we get. Okay, isolate, dung 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 dung. Isolate. Okay, add 10. Add 10 to both sides. Boom. See, this is our line. We're left with 2x equals 10. What's the next step to isolating x? The 2 is connected by multiplication, so we undo it with division. Divide by 2. X equals 5. We were talking about x being the independent variable, being time, seconds, tick, tick, tick. So the answer is 5 seconds. So, if an object is dropped from 400 feet on our planet, where it's getting pulled down at negative 16 t squared, or at negative 16 t squared, okay, it'll take exactly 5 seconds, according to our calculations, to hit the ground. All right, and I didn't have my calculator with me. If I had the calculator with me, we would be able to do more complicated problems. But we were able to solve that by factoring. Okay, so that's power, right? Okay, so we're going to have a balance of technology and your own brain power. Okay, so that's our quick pick lesson here at JFK Airport. And I want to see if we can get it. Oh, there's an airplane right there. Looks like it's coming in. Where's it coming from? Oh, probably from some nice sunny place. Maybe Hawaii. There's another one over there. Oh, nice. Okay. All right. Signing off. Now, it's time for the trek home. Signing off. Mr. P here.